You are listening to Climate Now. I'm Catherine Gorman.
And I'm James Lawler.
And James, when we're talking about climate change, I think one of the things that often comes up in this conversation is the cost, these sort of enormous, frightening numbers. You know, we need to do X by Y, or we're going to suffer all of these things. And they're always these sort of uncountably large numbers. But how do we actually get to those numbers, and how can we actually trust them or understand them?
So we were very curious about this question, really unpacking the methodology behind these projections of cost. What gets factored in? And what sorts of scenarios are not accounted for, if any? Really understanding how these costs are actually derived. So we reached out to Dr. Ian Bolliger, a climate data scientist with the Rhodium Group and researcher with the Climate Impact Lab, where they're quantifying the impacts of climate change sector by sector and community by community around the world. Dr. Bolliger, welcome. Thanks for joining us.
Thanks so much for having me.
So, Ian, could you give us your backstory? Tell us how you kind of got to where you are today.
So I grew up in Seattle and spent a lot of time outside. And so kind of had somewhat of a general appreciation for the outdoors and the environment and this general notion that we should be preserving it and working towards making sure that we have a habitable and vibrant environment. I studied math as an undergrad, applied math from the intellectual side. Anything quantitative was up my alley. So it was kind of in a job after college. I was researching global health, and it was this organization, the Institute for Health Metrics and Evaluation, that looks at the state of global health and kind of from a quantitative perspective. And I realized that it wasn't necessarily the climate or the environment itself that I was interested in. It was how humans interact with that climate and what the impacts are on society. So as I started to kind of think about what the burden of disease was in different areas, I started to kind of like make the connection between climate and human health, so environmental health and human health. And then I started working on economic impacts of climate change in particular, and that's kind of where I'm at now.
You know, there are so many kinds of feedback loops and processes that we just don't yet fully understand. And I wonder, could you talk about the uncertainty around probable costs of climate change and really, can we break down their potential impact?
I think just to start off by kind of discussing the framework that I like to think about climate impacts and how we kind of narrow down our overall uncertainty of what those impacts might be. And that's a framework of risk. We like to think about risk in many parts of our society, governments, financial systems, et cetera, all try and take these risks into account. And they're totally uncertain. You know, we don't know what the market is going to do next year. We don't know what sort of civil unrest there may be in different places around the world that could affect us. I like to think about climate change in a similar way. We don't have all the answers. We don't know exactly which places are going to warm by exactly how much and what that's going to do to extreme weather, et cetera. But we have estimates of these things. And we can take those estimates, that range of estimates of how we understand what the changes are to the physical system. And then we can build on that with our understanding of how humans respond to these physical changes. We can combine those two pieces of understanding and start to get a sense of what the overall impacts might be and what the range of impacts. There's always going to be a range, but if we can work to quantify that range, we can start comparing it to other things that we care about in society. So how much are we willing to invest in trying to mitigate these impacts versus investing in all the other really important things that we need to do as a society? Companies and governments are really used to this framework of quantifying risks, but they're not used to understanding, how do I take into account the fact that our shoreline is going to be disappearing? How do I decide whether I want to invest in that or I want to invest in schools or education? Like, those are both competing demands, but there's no way to kind of like decide how to allocate your finite resources. And so a lot of the recent efforts to try and make these things somewhat comparable, you're never going to be able to make them exactly comparable. They're different experiences that society has. But the more the academic literature can try and put these in the familiar context that businesses and governments and other actors are used to, the more we can actually use that information going forward.
So, following that thread, what would you say the trend is with regard to industry, businesses, governments, and investors? What's their level of hunger to access this research and make sense of it all and implement it?
Yeah, it's definitely more than lukewarm. It's not scalding maybe, but it's like enough to cook some pasta maybe. It's been really exciting to see. So these companies are realizing that these are risks that they need to account for. We like to talk about transition risks and physical risks. So a fossil fuel company, for instance, would be a prime example of this, will face transition risks as society starts to move away from the product that they offer. And then there's physical risk, which is most of what we work on, which is like a company may be exposed to increasing storms or increasing temperatures, et cetera. So what are the physical risks from climate change? On both those sides, there's been interest from the business side, but also from regulators. And so we have the task force on climate related financial disclosures. We have a variety of central banks that are starting to explore regulations on disclosures of climate risk within companies. I think valuable motivation for thinking about climate change from the risk perspective. If your sole goal is to make sure that society is as well adapted to climate change as possible and is mitigating climate change as possible, as much as possible, it's in your best interest to make this information available to companies, because it's also their directive as a company to make sure they price this risk. They have no incentive to price it too low because that's financially risky for themselves. They have no incentive to price it too high for similar reasons. So getting that number right is beneficial for society in terms of their ability to adapt to climate change, but also for any individual government or corporation that may be trying to do a thorough risk assessment.
What regulators are we talking about, and what types of businesses have broad coastal risks?
I will say that one kind of area that comes up in conversation a lot is the insurance industry. I work in tropical cyclones, and there's a lot of energy spent trying to figure out what the risks are to the portfolio that an insurance company is insuring. And taking it a step up, there's reinsurance companies which kind of diversify among the insurance companies. And so a lot of them are relying on these models that simulate thousands of years of storms to try and figure out what the risk is to all of their different assets. But there hasn't been yet a lot of work done to try and understand how that risk changes into the future. It's been more of a static assessment that looks at historical data and tries to gain information from that. So there's been a lot of interest in trying to understand what are the trends in these risks. And that's something that we're trying to do, which is to take this sort of framework that a lot of modelers use that are working with the reinsurance companies and start to inject some climate trends into it and see what that does to our understanding. So we can get a sense of, is this going to multiply a risk by 1.5, or is this like a 10 times multiplier? And those sorts of qualitative differences are really important for how you think about planning and how you think about a product like insurance as a whole. So that's certainly not the only way, and insurance is not the way to solve all of our climate risk problems, but that's one area in which it comes up a lot.
So, how big of a problem do these insurance companies have if they're not taking climate risks into account?
Without accounting for climate change, you're looking at, in the US alone, definitely tens of billions, potentially per year, that we're missing in terms of what our risk might be. And so some of the insurance companies and some of the modelers have done the initial forays were assuming there's like an X% increase in damages every year. And that's useful in terms of like scenario planning, but doesn't actually ground itself in the science of how these storms are changing. And so it's important to take the best available science from the climate science side and actually use that to adjust our understanding of the economic risks.
Really interesting, going up a couple levels. Can you talk about like the different categories of impact? So when we talk about climate change in general and the impacts it's going to have, what do we mean?
There are lots of different ways in which climate can impact society. And one of the main goals that our group, the Climate Impact Lab, one of the main goals of that group is to try and move sector by sector through the economy and understand how climate is impacting that sector. By doing this as a bottom-up approach, we can start to build up a better sense of what the cumulative effects of climate change are, rather than trying to just throw out a number without really knowing how each of the individual sectors are affected. You might imagine agriculture is a potentially big impact. Crops rely on having a certain type of climate in order to maximize their yields. So as you start to shift climates in different areas, farmers need to respond to that. In many areas, they may be shifting out of their ideal climates. Some areas may be shifting into ideal climates. So we try and make sure to take a sort of agnostic perspective on whether this is going to provide benefits or challenges. And in most areas, it provides challenges. But in some areas, cold places that are getting a little bit warmer and more hospitable, for instance, could allow for increased crop growth.
So can we go into a bit more detail here? How do you assess these impacts?
There are a handful of crops that supply the dominant majority of calories for the world. And so those are, it's not the only way to look at it. Obviously, calories is not a be-all, end-all metric of human nutrition, but it is kind of the first order thing that we care about when we're trying to make sure that the entire world can be fed. And so each one of those crops has slightly different optimal environments and grows better or worse in different conditions. And there's been a lot of research that tries to model those conditions, tries to take some of the actual chemical structure of the plant and understand from a process understanding where is this plant going to grow best or worst. And what we've actually done is taken a different perspective and just looked at the data. So we look around the world, we have data on how many, like what the yield of crops are in different regions. And we also have pretty good data on year to year how those temperatures are fluctuating in different regions. So we can actually see in the data, we can start to see, oh, in these areas, crops are growing better. And in these years, and particularly warm years in this one country, crops grew better or worse. And kind of aggregating all that data together from across numerous countries and over time, we start to get an understanding of how crops exactly respond to different climates. And that's difficult in and of itself, but the really tricky part is to understand how farmers are going to adapt. If it becomes too warm to plant a certain crop, corn, the farmers aren't just going to keep planting corn and not getting anything out of it. People are going to adapt. And so trying to model that is sort of the next stage of the work that our group has been doing. And again, we can pull from the historical data to see, as regions started to get colder or warmer, like how did they adapt and how did crops shift around? But that's the tricky part for sure.
So what about health impacts?
Human health is another big one. So both mortality from heat stress, so people just generally don't do well in hotter environments, as well as vector-borne diseases and other things you might imagine that kind of change their spatial scope based on climate. So as mosquitoes move north, as the northern climates get more and more warm, you might have more vector-borne diseases there. When we're trying to think about how do you understand the cost of human health, we've got this distinction between effects that are more gradual and more kind of common within the population that we can generally understand. Like if we have more heat waves, elderly populations are going to be at risk. That's a little bit smoother and easier to forecast. Things like global pandemics are a little bit more difficult to forecast because you can argue that environmental conditions played a role in the likelihood of the current pandemic, species being forced out of their habitats, more interaction between humans and animal species that leads to kind of the chance of that vector occurring is increased. Those sorts of things are, again, much trickier to understand. And what we try and do, again, is look to the past to understand the future. So there are many mechanisms by which climate change and increasing temperatures could affect health. And so we just try and look at the data and say, all right, when places got hotter or cooler, how did that affect their death rates? And that's certainly not the only way to look at it. We're going to be missing some things that are rarer. But in general, the past is sort of the best way we have to understand what these impacts may be going forward.
Could you talk us through the impacts to the labor force?
So people just work better and harder in a more comfortable environment. So you can imagine, if your room turns up to 95 degrees, you're going to slow down a bit. You're going to, need to take more breaks. The climate may have a greater impact for those people that are outside working, but regardless, it's going to have some sort of impact.
So how do you measure that impact?
You take a similar approach. We look at history, and in some areas we have really good documentation, surveys, government records, et cetera, of how much people are working, and we try and figure out how that changes as a response to temperature. In general, what we found is that it's much more substantial than we previously thought. Whereas other sectors, that's not always the case. Energy use in particular has always historically been thought of as being an extremely significant component of the economic costs of climate change. And our results are a little bit more muted. So there are areas that are going to obviously require more cooling loads, and that'll increase their electricity, but there are also areas that will require less heating loads. And so there's some of these impacts that are maybe larger than you might intuit yourself, and some that may be smaller.
So you've looked at agriculture, human health, labor force, and energy, but what about things like hurricanes or extreme weather?
Those are kind of the effects of sort of slower moving climate change. When we start to think about extreme weather, that's where you get these sharp discontinuities in terms of damages caused by individual events. So it's kind of a different approach that we take to looking at these slower moving changes versus, what happens if we get more heat waves, if we get more tropical cyclones, if we get heavier extreme rainfall events.
And what about larger, like second order kind of cascading impacts, like migration or geopolitical instability. Like last year, obviously, with the fires in California, there were stories about the migration effects that would produce within the United States, but other countries, obviously, the forecasts are far worse than that because it could be just catastrophic, right? Like you have huge movements of people that just completely destabilize governments that make all of these other calculations feel like pennies that you'd find under a couch versus the overwhelming costs of those kinds of effects.
Yeah. No, those are good questions. There's always going to be this sort of existential level of climate risk that we're not really able to easily quantify with the same methods that we use to look at some of these direct effects. And it takes a little bit of extrapolation and qualitative thinking about how do we understand what the second order effects would be if we start to change our economies drastically because agriculture is affected, because the labor force is affected. That may cause political instability. So there is research suggesting that climate does have an impact on conflict rates, the likelihood of conflict forming. You might imagine many mechanisms for why that could be income related or just general aggression related when it's hot. Just inherently, there's a limit to how much we can, put a number on what this risk is. And that's when we have to rely on people that are in decision-making roles to use judgment to understand how big of a risk this is. It may not be by any means a certainty that we're going to face massive political instability and migration around the world, but it's not out of the realm of possibility. From our research perspective, if we can mitigate the economic impacts, that's one primary mechanism that is driving migrations and conflict, et cetera, is that people are losing their livelihoods. The types of approaches, both mitigation and adaptation, that are going to address some of these first order impacts are also going to address the second order impacts. It's just sometimes or always way more difficult to put an actual number on those second order conflicts, even though they are very existential questions.
We've gone through the impacts of climate change sector by sector, but you also look at the impact community by community. What do you see there?
So we know in general that the relationship between temperature and all of these different sort of negative impacts that we might imagine is muted in wealthier areas. You might imagine that that's the case because they have more adaptive capacity. So if your area gets hotter, but you have the money to buy an air conditioner, you're much less at risk than if your area is getting hotter and your heat waves are getting longer and you don't have that access. That's one way in which that relationship can vary over space and across different communities. But another one, like you mentioned, is sort of the characteristics of the area. So places that have more potential vectors might experience a stronger relationship to increasing temperatures than other areas.
So we're talking about a system where there's some knowledge, agricultural impact, labor and energy impact, right? And we have an approximation of property costs due to cyclones and other extreme weather damage. But what about those bigger things that are harder to model? So these more sort of, either downstream events like conflicts over resources and migration, or sort of these tail risk events. Are those factored into social cost of carbon or some of these other costs that we've been talking about?
The sentiment that you're referring to is kind of what people call the streetlight problem or the street lamp problem, where, if you lose your keys, you're going to be looking in the light where you can see, but the entire street is much bigger than the small area that's illuminated by the light. And so just because you're looking where you have knowledge and have information, that doesn't mean the answer is there.
Yeah, that's a good way to put it. Yeah.
In general, probably what we're able to quantify is a lower bound, and that's better than zero. So the nature of the social cost of carbon is trying to internalize this externality. So start to account for these hidden costs that we don't see. So without the social cost of carbon, we are implicitly assuming that those costs are zero. And so any number that's greater than zero, but less than the true number, is going to be steps in the right direction. So the more that we can quantify, the better in terms of helping us make those decisions. The second thing I say, and this is not something that we do regularly or that is that common, but you could impose some sort of expert-derived probability distribution on some of these more extreme conditions. And if you, as a government, decided that this was your official position, you could incorporate that into the same kind of framework and decision-making that the social cost of carbon ingests. So as a theory, as a concept, this metric could account for all these things. It's just incorporating those more nebulous, lower probability, higher risk, harder to quantify events, that's just a harder thing to do. But it's not that the idea of the social cost of carbon can't account for them. It's just that we don't necessarily have that information.
Awesome. So thanks so much. It's been a pleasure to talk to you today.
Likewise. Thank you so much. It's been really fun. I appreciate the opportunity to be here.
Dr. Ian Bolliger of the Rhodium Group and the Climate Impact Lab. Okay, so health, agriculture, labor, severe storms, all of human existence. This is a lot to quantify.
Yes, especially as, we do live in a society where if you cannot express yourself in dollar terms, you will not be understood or even heard. So it's a good thing that the very smart people at the Rhodium Group and Climate Impact Lab and elsewhere are trying to put a number on these things so we really understand what we'll be facing.
If you're interested in the topic and you want to learn more about the costs of climate change and the social cost of carbon, you can check out our other episodes. Great ones to listen to are the ones featuring Bob Kopp and Tama Carlton, both experts in this area, and our video featuring Dr. Bolliger on the costs of climate change. And that's all on our website, climatenow.com. And if you've got a question or a comment and want to get involved in the conversation, tweet at us at WeAreClimateNow. And that's it for today's episode.